Welcome to Understand the Math. In the video description, you'll find a link to guided notes that can be downloaded and filled in as you follow along with the video. In this video, I'm going to explain how the side lengths are found for a 45-45-90 triangle and a 30-60-90 triangle. And then we'll derive the values for sine and cosine of an angle equal to 30 degrees, 45 degrees, or 60 degrees. Special right triangles are right triangles such as 45-45-90 and 30-60-90 that have particular relationships between their sides. Let's look at a triangle where the acute angles are each 45 degrees. I'm going to explain how to find the lengths of the two sides and the hypotenuse. We'll begin by labeling each side with a variable. The right side will label A, the bottom leg will label B, and the hypotenuse will label C. The Pythagorean theorem gives us a relationship between all three sides. That relationship says that the leg squared, which will be A squared, plus the other leg squared, which is B squared, is equal to the hypotenuse squared, which is C squared. Because A and B are opposite the same size of angle, they're equal. So we'll let B equal A in our equation. So that gives us A squared plus A squared is equal to C squared. This gives us 2A squared is equal to C squared. If we solve for A squared, we get A squared is equal to C squared over 2. And then we can solve for A, and we find that A is equal to C divided by root 2. And then we'll also remind ourselves that A is equal to B, so B is also C divided by the square root of 2. Let's now put these values on our triangle. A is C divided by the square root of 2. B is also C divided by the square root of 2. And then our hypotenuse is C. It's common in trigonometry to let C equal either the square root of 2 or 1. So in the triangles in purple down below, we're going to fill in values for C. So on the one on the left, let's let C be equal to the square root of 2. So if the C is square root of 2, then both legs are equal to 1. On the triangle on the right, we'll let C be equal to 1, and both legs will be equal to 1 divided by the square root of 2. I see that I had not erased 1 over root 2, so we didn't have to fill that one in. That one was already there. Let's now look at a triangle where our acute angles are 30 degrees and 60 degrees, and we'll find the lengths of each side of the triangle. Let's begin by labeling each side. The right-hand side will label A. The bottom will label B, and the hypotenuse will label C. We can now put two of these triangles together. Let's go ahead and label these triangles. So the side opposite the 30 degrees is A. So this is A, this is A. The side opposite the 60 degrees is B. So that's B. And then the hypotenuse is C. What we're going to notice now is that this angle is 60 degrees. So that means if all the angles of the triangle are the same, then all the side lengths are going to be the same. So for us, that means that 2A is equal to C, or A is equal to C over 2. To find the other sides, we're going to use the Pythagorean theorem. So that says A squared plus B squared is equal to C squared. And now let's plug in. So we know A is C over 2, and that quantity gets squared. B we don't know, so we're going to write that as B squared, and then our C squared is on the right-hand side. If we multiply this through, we have C squared over 4 plus B squared is equal to C squared. Let's put the C squared over 4 on the right-hand side so that we can solve for B. So we have B squared is C squared minus C squared over 4. So this gives us 3 over 4 C squared. And then we can take the square root of both sides and find that B is equal to the square root of 3 over 4 C squared, which is the square root of 3 over 2 times C. Let's now put these values on our triangle. So the angle opposite the 30 is A, and we found A to be C over 2. The angle opposite 60 degrees is B, which is square root of 3 over 2 times C, and then our hypotenuse is C. So just like before, we're going to substitute in some values for C. The most common values are to let C be equal to 2 or C be equal to 1. In our picture on our left, we're going to let C be equal to 2. So if C is 2, our bottom length is equal to root 3, and our side length is C over 2, which is 2 over 2, which is 1. On our right-hand triangle, we're going to let C be equal to 1. This one's a little bit easier. So our bottom length is the square root of 3 over 2, and our side length is 1/2. We'll end this video by finding values for sine and cosine functions for these special angles. Let's start by labeling the sides of both triangles. I am going to choose to label the sides with a hypotenuse being equal to 1. So we have a 1, we have a 1 over root 2, a 1 over root 2 for our 45, 45, 90 triangle. For our 30, 60, 90 triangle, our labels are going to be the hypotenuse is 1, the right-hand side is 1/2, and the bottom side is the square root of 3 over 2. Let's now fill in the values for sine and cosine for the special angles 30, 45, and 60 degrees. We'll begin with the 30 degrees, and let's go down and let's highlight 30 degrees. The sine of 30 degrees is going to be the opposite over the hypotenuse, so that's going to be 1/2. The cosine is the adjacent over the hypotenuse, so that's root 3 over 2. For our 45, 45 degree triangle, you can see that the sine and the cosine are going to be the same. The sine is opposite over the hypotenuse, which is 1 over root 2, and the adjacent over the hypotenuse is also 1 over root 2. And then the last angle we'll look at is our 60 degrees. The sine is opposite over hypotenuse, so that's root 3 over 2. And the cosine is the adjacent over the hypotenuse, so that's equal to 1/2. In other videos, I'll talk about the unit circle, and I will talk about ways to memorize these values that will be a little bit easier. These values are used a lot in trigonometry, pre-calculus, and calculus, so they definitely need to be memorized.